Now this question is one that has to do with bonding. Now obviously when we're looking at CH3 OH methanol, we're going to have three H's, an O and an H, and you should recognize that in this molecule the forces of attraction between it and another methanol will be to do with the fact that this has ability to hydrogen bond. Anytime you have an H bonded to an N or an O or a fluorine, there's a possibility of that arising. Now this here is the dipole that gets created because oxygen is so much more such a greater electronegativity than hydrogen. The electrons here will be pulled over, and there's only one electron and one proton in hydrogen, so when that moves across we're really kind of almost leading an exposed proton. And this itself isn't a bond, but the attraction that this would have for another molecule, so if we had delta negative there, delta positive, and we had the rest of a methanol on this side here, it would be, this would be the hydrogen bond here. And this is the strongest bond that we can get in intermolecular bonding. Okay, so it's no surprise to see that that's got the highest boiling point. Now what's unusual here though is chlorine is a much more electronegative atom than bromine. It's higher up the periodic table, heading towards fluorine, which is the strongest of all. However, bromine is going to have a higher boiling point at 4 degrees. Now when we look at these two molecules and the fact that chlorine's minus 24 degrees Celsius and bromine's 4 degrees Celsius, there's only two types of bonding that we're really considering here. One is that all molecules are going to have temporary dipole bonding or dispersion forces, so they both have those, and to some degree they both have permanent dipoles. Now you'd expect the chlorine to have a stronger permanent dipole, and bromine you'd expect to have a weaker permanent dipole there. Now obviously if we're looking at this and we're thinking to ourselves, well, surely the stronger permanent dipole is a very important factor. The fact that we have minus 24 degrees compared to 4 can only mean one thing, that the temporary dipole bonding must be a bigger factor. And obviously when we're looking at bromine, there are considerably more electrons there than there are in chlorine, so the fact that this higher number of electrons in this molecule means that has resulted in the temporary dipole bonding being the most significant factor, and this is what we have to explain in our answer. So in talking about this, we should obviously mention that methanol's hydrogen bonding, should explain how that actually occurs, that it is the strongest intermolecular bond, and in talking about it, obviously we need to talk about the electronegativity of oxygen, and that it being so electronegative attracts the electron pairs in that shared bond towards itself, and it creates a fairly large dipole. And it's the attraction between the molecules that's the hydrogen bond, the methanol molecules. And it takes a lot of energy to break this. This isn't a complete written answer here, I'm just written some key points. So obviously if it takes more energy, it's going to have a higher boiling point and melting point. When we look at bromine, first of all it's got a larger molar mass, so there's going to be more electrons, so it's going to have a larger temporary dipole, and so stronger attractions to other bromomethyl atoms. And then we look at CH3Br, and it's got a larger molar mass. There's more electrons, so there's going to be stronger temporary dipoles and stronger attractions to other molecules. Now, The thing you really need to bring out is the fact that chlorine is more electronegative than bromine, so you would expect CH3Cl to be a more polar molecule, and you should make that statement, and therefore the permanent dipoles are going to be stronger. And however, the fact that CH3Br has a higher boiling point can only tell us one thing, that temporary dipole bonding must have a greater impact overall, and so we need to bring that point out, and that's that question.